So the last step that we stopped at is to run our analysis. From here we will go to unsteady flow analysis and then determine the starting date and the ending date of our analysis and also the computational interval, and then say compute. And it will take, like, it depends on the mesh size that you take and also the computational interval, so it might take like from few hours to days. And after you hit compute and your software is done with the analysis, you will show your results on the RAS mappers. So we will open the RAS mappers right now. So here is our terrain, or the digital elevation map. It's high resolution digital elevation map with 1.5 meter accuracy, and it shows here how it's accurate, how is the roads and bridges and levees are well represented in this high accuracy digital elevation map. So all what we have to do, just zoom out and let's click on the depth, and let's so we need to hit here plan 01, and here is how it look like. Let's show the animation from the first time step, and here is how is the water flow is keep going from the upstream to the downstream. So this is the flood simulation. If we want to make it more fancy, so we will add a map layer and web imagery layer. So let's pick world imagery and say okay, and we can keep it here. So, and then back to the maximum, and we can show here the maximum water depths for the simulated area. So if we zoom in, we can show how is the water. Please look at this. This area didn't get flooded because we have the interstate or the highway road form a barrier that doesn't let the water to overtop the road and goes inside our area. And let's see how the water goes in. Yeah, here how it goes in. So when the water was still before the interstate, so no water is coming from here, and let's say we have some little overtopping from here was like less than 1 feet flood depths. And when water approach, when we approach to the Lumber River in this area, so we will find that we got some water come from the underpass here, and we have some little overtopping from here, like we have like 1 foot or 2 foot of water in the interstate, and here's the levee, and here's how the water goes in from here to there. And if we want to make it more clear, so let's show some fancy arrows, and here's how the water goes in. We have some water goes from here, some water overtopping from here, and if we keep going, will be something like this. How is the water is getting through. Yeah, let's zoom out and have a better picture. Yeah, so here's how it looks like. Where is the maximum water? So we got like 5 feet of water here, 6 feet of water, 5. So you can put the crews anywhere to get the flood depths. And if you want the flood velocity, let's pick flood velocity, and here it shows the maximum flood velocity here. So we have less than a half a foot water velocity, which is not damaging characteristics because the water is moving so slow. And let's hit water surface elevation and pick maximum. So this gives the absolute water surface elevation measured from the datum, Like here's 122 foot, here's 122 foot. So the flood depth that we got is the subtraction from the water surface elevation is the subtraction of the ground elevation from the water surface elevation. So if you subtract 122 by the elevation from the digital elevation map, so we can get the flood depth. This map. So we usually use the water surface elevation and subtract not from the ground elevation but subtract from the verse floor elevation. So let's move to another important point, which is the accuracy of the digital elevation maps. So this analysis is based on 1.5 meter digital elevation map, which is considered a high resolution, and let's show apple to apple like how I would perform the other accuracies, which is the 10 meter digital elevation map. Alright, so let's make it like this, and we have another model here, and let's open this model is based on a 10 meter digital elevation map. Yeah, let's minimize it and let's put it here. Yeah, let's first compare between the digital elevation maps and how is the accuracy is. So let's remove the imagery layer and let's remove this layer. And can you see the difference here? So let's zoom in. Let's zoom in here. Here's it shows more accurate. If we keep zoom in on this map, so we might get more accuracy here in this point. But here it just like this because it's a 10 meter by 10 meter, so it captured the difference and the elevation each 10 meter by 10 meter, but here it capture every 1.5 meter by 1.5 by 1.5. Look here, how is the interstate look like, and look here, how is the interstate look like. So it's obvious this is a high accuracy one, more accurate one. So let's now shows the water, how this resolution could impact the flood hazard map. So let's back to the imagery layer here and the imagery layer here, and let's see the flood depths here, and let's zoom out. This is the maximum flood depths, and here let's zoom out and let's show the maximum flood depths here. So here is the maximum difference in the water extent. So as you can see, the water extent is something like this, and we don't have any water here, but here the water extent is more. We have water in this area. Let's investigate why this happened. So let's see how is the water moving here. Yeah, let's zoom in here. Yeah, so let's go back. So now the water didn't feel the interstate because it wasn't well represented in the digital elevation map. So if we keep moving, so you can see now the water is not feeling the road because of the accuracy of the digital elevation map. So it overtopped the road and keep going into the city. But here, let's stop here and let's go back in this map. Yeah, let's zoom in. Yeah, so now we can see as the water keep going, like let's go back a little bit and let's keep it moving and keep this. moving. So now the water is filling the interstate and it keep retaining water. There is no overtopping and it keep going until some point that has low elevations. We have some little overtopping, and if we keep getting more accurate digital elevation map, I would expect more differences, but this is the most accurate that we can get right now. So now this is more accurate in terms of the flood extent. Let's check what could happen in terms of if we compare between the flood depth values. So now let's pick 2 points. Here we don't have any water, but here we have like 1.7 foot water. And let's check a point here. So we have here 10 point or 11 foot of water, but here we have 13, so it's 2 foot of water difference. And let's check someplace like almost here, and let's do the same here and click maximum, and let's check the water in this area. So it's a 5 foot. If we check it here, it's 5.5, and here's 1.6, here is 2, so there's a difference, and we need to zoom in to make the places more accurate. So here's a 6.6, here is 6.5, so there's some difference in some places in terms of flood inundation map extent, and also in terms of the flood depths. So resolution matters, and it makes high differences in terms of the flood extent and also the flood depths. So it's more essential to get high resolution digital elevation maps, so you could have accurate flood hazard maps. So let's zoom back here. Back here, and let's make it maximum and stop running. So here it looks more reasonable, and let's investigate one last thing in the digital elevation map and see how is the road look like in H1. So if we zoom in here, and if we zoom in here, can you see the details of the road? We have everything is captured here, but here we have only little things that is captured here, which describes and explains why is this difference in the flood hazard map. So I think that's enough in terms of detailing the hazard map.